A 4 billion-year-old rock sat buried in the dirt. It was heavy, reddish-brown, and completely unimpressive. Ancient farmers walked right over it. Builders kicked it out of the way. Children used it to build dirt walls. To anyone looking, it was just ordinary mud pressed hard into stone. Yet inside that completely worthless rock was the exact material that would eventually construct every skyscraper, carry massive freight trains, build ocean-crossing ships, and forge the heavy machinery that lifted billions of people out of extreme poverty. But for almost all of human history, that red rock just sat there, totally ignored. The real mystery isn't just how we stumbled upon iron. The mind-bending question is how an ancient human, with no periodic table, no degree in chemistry, no books, and zero blueprint, could stare at a dull chunk of red dirt, throw it into a fire, and somehow pull out a metal that Stone Age technology had absolutely no business creating. The answer is one of the wildest survival stories in human history. And surprisingly, it doesn't start underground. It starts in outer space. To appreciate just how insane the discovery of iron really was, you have to look at the world before it. For nearly 2 million years, humanity was stuck in the Stone Age. Flint, obsidian, and hard river stones were the peak of human technology. You could chip them into sharp edges to skin animals or cut meat, but they were incredibly brittle. If a stone axe hit a thick bone, it shattered instantly. And once a stone tool broke, that was it. You couldn't melt it back together. Then, about 5,000 years ago, everything changed. People in the ancient Near East figured out how to extract copper. It felt like absolute magic. They noticed that certain greenish, blue-tinted rocks placed in an intensely hot fire would melt into a glowing liquid metal. When it cooled, you could shape it into whatever you wanted. Copper could be hammered, molded, sharpened, and resharpened. But copper had a massive flaw. It was way too soft. Hit a tough tree trunk, and your copper blade just bent in half. So early metalworkers tried a bold experiment. They mixed copper with a tiny bit of tin. The result was bronze, a metal far harder and tougher than either element on its own. For 2,000 years, bronze ruled the world. Empires were built on bronze swords, bronze armor, bronze plows, and bronze chisels. But bronze had a huge strategic vulnerability. Copper was easy to find, but tin was ridiculously rare. Tin was only found in a few isolated pockets on Earth, like modern-day Britain and Central Asia. To make bronze, ancient empires had to build massive, fragile trade networks, spanning thousands of miles. Sailing ships hauled tin ingots all the way from Cornwall down across the Mediterranean. Caravan trains dragged tin across mountains from Afghanistan. If a single war broke out, or a sea storm sank a few trading ships, an entire empire was cut off from making weapons and tools. Meanwhile, the ultimate solution to their tin problem was sitting directly underneath their feet the entire time. They were literally standing on it. Iron is the fourth most common element in the Earth's crust, making up over 5% of the ground beneath us. Entire mountains are packed with it. The reddish color of dirt and clay across the globe is literally just iron oxide, plain old rust. Almost anywhere on Earth, iron is just a few feet away. Yet for thousands of years, brilliant civilizations that built giant pyramids, wrote epic poetry, and created complex legal codes couldn't do a single useful thing with it. Why? Because iron plays a sneaky chemical trick on us. Unlike gold, which glitters in riverbeds as pure metal, or copper, which sometimes appears in raw reddish nuggets, iron almost never exists as a pure metal on Earth. Iron has an obsessive chemical attraction to oxygen. Over millions of years, exposure to air and moisture turns raw iron into rust. Every speck of natural metallic iron on Earth's surface was long ago converted into dull red stone. When an ancient human looked at iron ore, they didn't see a hidden metal, they just saw a useless red rock. But there was one crazy exception, and it fell directly from the sky. Metallic meteorites are frozen chunks of ancient asteroid cores. When one of these space rocks survives the burning fall through our atmosphere and hits the ground, it delivers something that simply doesn't exist naturally on Earth. Pure, solid metallic iron mixed with a little nickel. These space rocks blew ancient minds. They were unnaturally heavy and magnetic. When you smashed them with a hammer, they didn't shatter like normal rock, they dented. When cut open, they gleamed with a bright metallic shine. Ancient cultures instantly realized these rocks weren't from this world. In ancient Egypt, hieroglyphs called iron black copper from heaven. Sumerian texts referred to it as metal from the sky. Hittite tablets called it the celestial black metal. Long before humans ever mined iron from the earth, they were crafting ultra-rare treasures out of fallen meteorites. Archaeologists found 5,000-year-old iron beads in Egyptian tombs crafted entirely from space rock. When researchers scanned the famous iron dagger found inside King Tut's tomb, tests confirmed high levels of nickel and cobalt, the distinct chemical signature of a meteorite that landed in Egypt millions of years ago. During the Bronze Age, sky iron was 40 times more valuable than silver. Kings traded tiny iron rings as priceless royal gifts. But you can't build a civilization on falling stars. Transforming ordinary ground rock into usable iron required something humanity didn't have yet, a completely new kind of fire. Here's the physical barrier that delayed the Iron Age for thousands of years. Copper melts at around 2,000 degrees Fahrenheit. Bronze melts even lower. Ancient pottery kilns could easily reach these temperatures, allowing metalworkers to melt copper, pour it into clay molds, and cast tools effortlessly. But pure iron doesn't melt until a blistering 2,800 degrees Fahrenheit. That 800-degree gap was a brick wall for ancient technology. Bronze Age furnaces were physically incapable of melting iron ore. When early blacksmiths accidentally dropped iron ore into copper furnaces, expecting liquid metal to pour out, nothing happened. The rock just sat there glowing red-hot, completely solid and stubborn. Logic told them iron was just useless trash. Unlocking it required a radical realization. You don't need to melt iron to extract it, you just need to strip away its oxygen. The breakthrough didn't happen overnight. It was a slow buildup of furnace upgrades over centuries. First, smelters swapped raw wood for charcoal. Charcoal is pure carbon that burns far hotter, cleaner, and more consistently than timber. Second, they built tall clay chimneys. As hot air rose up the column, it naturally pulled fresh oxygen into the bottom, creating a roaring draft that pushed temperatures higher. Third, they invented hand-pumped leather bellows. Blowing forced air directly into the burning charcoal pushed furnace heat well past 2,200 degrees Fahrenheit. Now, picture what happened next. A Bronze Age smelter tosses reddish iron rocks into a blazing charcoal furnace, perhaps using it as a chemical flux to help refine copper. Inside that enclosed furnace, the burning charcoal starves for oxygen and produces a heavy cloud of carbon monoxide gas. Carbon monoxide is chemically aggressive. As it rises through the furnace, it grabs the oxygen atoms right out of the iron ore. It doesn't melt the ore at all. It chemically strips it clean while it's still solid. When the smelter opened the furnace, they didn't find a pool of liquid metal. Instead, they found a dark, ugly, spongy lump of metal mixed with glass-like trash, called a bloom. It looked like a burnt cinder, but when they hit it with a heavy hammer while red-hot, it didn't shatter. It bent. It squished. It was malleable metal. What makes this discovery so incredible is that ancient smelters mapped out this entire chemical process through pure trial and error. They had no idea what carbon monoxide was, but they learned to read the fire. They knew that a bright yellow-white flame meant the furnace was ready, while a dull red flame meant failure. They memorized the exact ratio of charcoal to ore, the precise rhythm to pump the bellows, and the exact moment to break open the clay wall. That crude clay cylinder was called a Bloomery furnace. Once the spongy iron bloom was pulled out, the real muscle work began. The blacksmith took the glowing 1,000-degree bloom to an anvil and hammered it relentlessly. Every heavy blow squeezed out the trapped glassy slag and forced the microscopic iron particles to fuse together at an atomic level, a process known as solid-state diffusion welding. The result was wrought iron, a tough, low-carbon metal that wouldn't shatter under stress and could be hammered into sharp edges over and over again. But wrought iron still had a major flaw. It was relatively soft. A wrought iron sword would bend if it hit heavy armor. The secret to making it indestructible was an invisible element, carbon. Blacksmiths noticed that if you left wrought iron burying inside glowing charcoal fires for hours, the metal absorbed carbon from the fuel, transforming soft wrought iron into rock-hard steel. By plunging that hot steel into cold water, a process called quenching, they trapped the carbon atoms into a hyper-hard crystal structure. Now, they had a metal that could slice right through bronze. Around 1200 BCE, catastrophe struck the ancient world. In just 50 years, nearly every major empire in the Mediterranean collapsed. Trade routes crumbled, and the international supply of tin completely dried up. Bronze became impossible to make. Starving for tools and weapons, civilizations were forced to turn to the red rocks sitting in their backyards. Necessity forced humanity to embrace the Iron Age. As iron tools spread, metal was no longer reserved for rich kings and elite armies. Iron ore was everywhere, meaning any local village could build a clay furnace and forge its own tools. A humble farmer could finally afford an iron plow that cut deep into tough soil, unleashing an agricultural boom that fed millions. The local blacksmith became a legendary, almost magical figure in every culture, a craftsman who could literally turn red dirt into unstoppable tools. Over the following centuries, different cultures perfected the craft. In China, inventors built massive blast furnaces powered by water wheels, reaching temperatures hot enough to produce liquid cast iron over 1,000 years before Europe. In India, smiths created Wrought steel, the legendary metal behind Damascus steel blades that could sever floating silk scarves. Fast forward to the 19th century, when Henry Bessemer invented a giant converter that blasted air through molten iron, mass-producing structural steel in minutes. That single invention built the modern world, the steel girders holding up skyscrapers, the rails crossing continents, the bridges spanning oceans, and the engines driving modern industry. The next time you look up at a towering city skyline, remember this: every beam of steel above you is just a piece of dull red dirt that humanity learned to tame through fire, patience, and 3,000 years of stubborn curiosity.